All right, let's talk about Artemis II. This mission is so much more than just another test flight. It's really the key that's going to unlock our future in deep space. So in this explainer, we're going to dig way past the headlines and show you what really makes this mission tick. So you've probably heard this, right? Is Artemis II just a dress rehearsal? A low-risk practice run before the main event? Well, that's the common thinking. But honestly, the reality is so much more exciting. And this right here really sets the stage for everything we're going to talk about. It's kind of like a tale of two missions. Over on one side, you've got the myth, this idea that it's just a safe little shakedown cruise, checking some basic systems near Earth. But then you look at the other side, and that's the reality. This is a full-on decisive validation against the actual dangers of deep space. We're talking about pushing this thing all the way out to the lunar frontier. We've all kind of gotten used to this whole dress rehearsal idea for space missions, right? I mean, it made perfect sense back in the Apollo and shuttle days. You do your tests in the relative safety of low Earth orbit. But here's the thing. That's an old playbook. What worked back then, it just doesn't cut it for what Artemis II is trying to do. No, this isn't practice. This is the final exam. And it's happening in the most unforgiving classroom you can possibly imagine. That huge, empty, dangerous space between the Earth and the Moon. It's a complete end-to-end test, happening right where it matters most, where the stakes are absolutely the highest. And just look at this flight path. This is what makes it such a beast of a test. The mission plan has that massive engine burn to actually escape Earth's orbit. That's the translunar injection. And then it flies out on a path that takes it, over 370,000 kilometers away. The whole point is to intentionally expose Orion to all the stresses and hazards you just can't fake here in our backyard. Okay, so what are these dangers we keep talking about? What is Orion really up against out there in this deep space proving ground? Well, it really boils down to two huge, terrifying hurdles: incredible, unimaginable fire, and a silent, invisible threat: radiation. Get a load of this number. We're talking about almost 11 kilometers per second. That is just mind-bendingly fast. That's the speed Orion is going to hit our atmosphere with on its way home. A speed like that creates friction and heat that is, get this, about half as hot as the surface of the sun. Just think about that. Surviving that is, it's a monumental challenge, to say the least. Okay, so you're probably asking, how in the world does anything survive that, right? Well, the answer is this really clever strategy called ablation. It's basically a self-sacrificing heat shield. The whole idea is that as it gets insanely hot, the outer layers are built to just burn up and flake off. And as they do, they carry all that deadly heat away with them. It's an incredible way to keep the crew and the spacecraft inside nice and safe. And it gets even cooler. Orion doesn't just cannonball straight into the atmosphere. It pulls off this amazing move called a skip entry. It's literally like skipping a stone on a lake. It hits the top layer of the atmosphere, uses its own shape to get a little bit of lift, and kind of skips back up for a moment before coming down for its final controlled descent. It's a genius way to bleed off speed more gently, which lowers the peak heating and, just as important, reduces the crushing G-forces on the astronauts inside. But the heat is only half the battle. The crew also has to deal with that invisible threat I mentioned, radiation. As soon as you leave Earth's protective magnetic bubble, you're just bombarded by it. And this chart really puts it into perspective. The radiation dose on this mission could be anywhere from 100 to 200 times higher than what astronauts get on the International Space Station. That's not a small difference. It's absolutely staggering. And that's why this mission is the ultimate stress test for all of Orion's defenses. The spacecraft is packed with features designed to protect the crew. You've got this special hardened hull, you've got water shielding, and of course, super important, all the electronics are radiation hardened and have triple redundancy. Every single one of these systems is going to get pushed to its absolute limit out there. Okay, so let's say Orion can handle the heat and the radiation. That's great. But there's another huge piece of the puzzle. Can it fly itself? I mean, we're talking about being hundreds of thousands of kilometers from home. There's no GPS out there to tell you where you are. And the communication delay with Earth means mission control can't just fly it with a joystick. The spacecraft has to be smart enough to know where it is and where it's going completely on its own. So how does it do that? Well, it actually goes back to the basics of exploration, but with a super high-tech twist. It navigates by the stars.
Orion has this optical navigation camera that's constantly taking pictures of Earth, the Moon, and the star patterns around it. Then, it uses those images to triangulate its own position, and it's ridiculously accurate. We're talking pinpointing its location to within 100 meters, even when it's all the way out by the Moon. It's just incredible.
But here's the real kicker. It's not enough for the heat shield to work, or the navigation to work, or the radiation shielding to work in isolation. They all have to work together, perfectly, for the entire 10-plus day mission. That means life support, power, cooling, propulsion. Every single critical system has to perform flawlessly as one big integrated machine. There's no room for error. So, okay, we've talked about all these insane challenges. What's the big picture? Why go through all this trouble? Why put Orion through such a grueling test? Well, the answer is actually pretty simple. This mission right here, this is the real road to Mars. And this table just lays it out perfectly. The connection is so direct you can't miss it. Look at the reentry speeds, the radiation doses, the need for the spacecraft to fly itself. Every major challenge that Artemis II faces is basically a preview, a scaled-down version of the even bigger challenges we'll face on a trip to Mars. The bottom line is this: you absolutely have to prove you can do this at the Moon before you can even dream of going to Mars. You see, for decades, there's been this huge knowledge gap. We know how to fly in low Earth orbit, we've got that down, but we don't have the real-world data on flying humans in deep space for long durations. This mission is what closes that gap. A successful Artemis II gives us all the hard data, the real-world experience we need to finally and confidently design the ships that will take us to other worlds. So let's just say it one more time, loud and clear. Artemis II is not a rehearsal. It's the final exam. It's exactly what this quote says. It is the decisive proof of concept. It's the mission that proves once and for all that we have the tech, we have the skills, and we have the procedures to safely send people out beyond our home planet. And that brings us to the ultimate question, doesn't it? If Orion aces this test at the Moon, are we finally ready to take that next giant leap? This is the mission that's going to give us the answer. It'll tell us if we're truly ready to go back to the Moon to stay, and then to push onward to Mars. By proving itself in the harsh reality of deep space, Artemis II isn't just a test flight. It's paving the only road there is for humanity's future among the planets.